The purpose of this video is to show you how to calibrate displacement transducers using our calibration tool software and the DCDT calibration apparatus. So you're going to take your DCDT and insert it into the DCDT block, and the first few times it'll be a little bit difficult because the anodizing will have raised the surface just a tiny bit, but that will wear in very quickly. And just get it so that a little bit of the DCDT is protruding through the front for most models. For very long reach models, you might have to play with that a little bit. And loosely tighten the thumb screws. These are just aluminum, so you don't want to tighten them too much, just snug will be fine. Next, you're going to get the core nuts, of which there are 2. And the larger core nut with the flange goes on the transducer core with the flange facing backwards. Like that. Then it's going to go through this plate with the other core nut going on with the flange facing forwards. And you want to just barely snug this. You want the core to still be able to move. Now you're going to move the carriage so that the core goes into the DCDT, and once that's aligned, tighten the core nuts. Leave the carriage free for the moment. Using the adjustment screw on the stage, move the stage so that it is centered and the edges of the stage are flush. Zero the gauge by pressing the 0 button. Now go ahead and apply power to your transducer. In the calibration tool software, we're going to give this transducer a name. I'm going to call it transducer 1 and a calibration unit. This readout reads in inches. For the input channel, you're going to browse and select the channel that the transducer is on, which in my case is MIDAC1 AI0, and select OK. Now you're going to select a sampling rate. If your system can sample 10,000 samples a second, and that's what you normally run, that's great. This system we're going to run at 1,000 samples a second, and you can select how many seconds you would like to average, 1, 2, up to however many. Generally, somewhere around 1 or 2 is just fine unless you have significant noise problems, in which case there may be some other things we can do to help your system. Now we're ready to start a calibration, so you click the Start button. The voltmeter in the upper right here shows you the current voltage sensed by the system from the transducer. So we're going to move the core until that gets very close to 0. And that's plenty close enough. We're talking within 100 millivolts or so. And I'm going to lock that down so that the core does not move. Now we're ready to start a calibration. You can do this however you'd like. I like going to one extreme and working all the way up to the other. And then you can work back down. This transducer is a plus or minus ½ inch transducer, so 1 inch total range. And this system is capable of calibrating transducers that are up to 2 inches of travel. So I'm going to go down to about minus ½ inch here, somewhere in that neighborhood. And as you can see in this particular setup, that's producing about minus 5.3 volts. Now all we have to do is make sure our cursor is in the calibration value area and press the button on this box that connects the readout to the computer. When we do that, it types the value from the readout into the box, averages the voltage for 1 second, and plots the point on the graph. Now we can crank a few turns in and press the button again. And we don't have to be precise with these movements because they're precisely recorded from this digital indicator. And you can go however fine you would like. We're going to go relatively coarse for purposes of the video. But as you can see, you can take all of these points and just maybe a minute, or if you're taking a very dense point sampling, maybe every 2 minutes. So it's much quicker than calibrating transducers any other way. So we're going to take a few more on the way up. As you can see, it's building the calibration curve in real time for us. And if we go off the ends of the transducer, I'll go a little bit past here, we can see that nonlinearity starting to creep in, so we know the exact range of this transducer. In fact, this transducer is slightly nonlinear on both ends. Now I'm going to come back down and add a few calibration points going in the other direction. And this just lets us know that we have no hysteresis in our sensor. You see they're falling very well in line in between the other calibration points. All right, so let's say that I'm happy with this calibration now. What we're going to do is click the Complete Calibration button, and then we're going to click Save. I'm going to save it as My Data. And now we'll open that My Data file. I'm going to open it just using Notepad. As you see, it tells you it's a calibration record, the sampling rate, the seconds that you averaged, the name of the transducer, the unit, what channel it was calibrated on, the slope, intercept, and then all of the raw calibration points. So as you can see, it's very easy to set up and use the DCDT calibration apparatus, and you can calibrate transducers in just a couple of minutes.